Hi, my name is Keegan Hunt, and today I will be showing you how to make an AC to DC converter with a smoothing filter circuit. The voltage will also be regulated to 6.8 volts and will power a 555 timer. Before we get started, I need to mention that Felstat seems to glitch out visually when we use the circuit, but everything else works. When you put it together on the breadboard, it won't have these visual glitches. Firstly, we have our transformer, which we have 120 volts, so we're stepping down from that to 60 volts using a turns ratio of 1 to 2. And then we connect it to our AC to DC converter. This works by taking AC, which is alternating current, and directing it, which converts it to DC, which is direct current. The diodes have an anode and a cathode. The cathode blocks electrical flow from entering, while the anode accepts electrical flow. The way we set up the diodes and hooked up the transformer to the circuit, we direct the current to go the way we want it to. We wouldn't be able to put this electrical flow to use due to the large rippling that occurs, but to rectify the problem we do just that. We use a full wave rectifier. To do this, we use a capacitor and a load resistance to smooth out the ripples. And we know that a capacitor allows AC components and blocks DC components of current. So when the DC current that contains both DC components and AC components reaches the filter, the DC components experience a high resistance from the capacitor, whereas the AC components experience a low resistance from the capacitor. We also know that current always flows through the path of least resistance. So that means that AC components will go through the capacitor while DC components will continue onwards, which will give us a pure DC current instead of a pulsating one with rippling. So now that we have our current figured out, it's time to get our voltage regulated. To do this, all we need to do is use a Zener diode, which functions similarly to a regular diode, except that it has a low breakdown voltage. When the breakdown voltage is met, current will flow through it to a maximum, which is determined by these series resistors, which equal up to 1,470 ohms, and it will stabilize and remain constant. The model we are using has a breakdown voltage of 6.8 volts. It then goes on to power our 555 timer chip, and if you haven't yet, check out our video on making an Astable Multivibrator Circuit, which is what we are powering today. But a quick run through shows that the 100 microfarad capacitor charges up and then discharges, which causes the trigger to activate and deactivate, causing our LED to blink on and off. Like I said earlier, the Felstat program has a bit of trouble and glitches out. When you actually build it, it won't have the flickering. We used a 470 ohm resistor and a 560 ohm resistor in parallel to create a resistance of roughly 255.5 ohms to help limit the current. And taking a look at the values, we can see that roughly we have a 6.8, which is 6.771, which is essentially 6.8 volts. So our regulator is functioning. And now let's go and put it together on the breadboard.